Good afternoon, everybody. This session is about analytics, data science, and we are very happy, we are pleased to have Aarti Kapur with us to conduct this workshop. She is an MBA from ISB Hyderabad. She did her BTech from IIT Delhi, and she is also MS in Transportation from University of Texas, Austin. Her passion is analytics. Currently, she is working as the principal consultant at Fractal Analytics, where her role is to build the environment by bringing together and codifying Fractal's IP algorithm and analytic solution, and diverse consulting experience on a best-of-class technology platform to enable advanced analytics and deep learning at scale with speed. And she has also in the past consulted with major market leaders for business, cooperation planning and marketing effectiveness. So let us all welcome Aarti to the stage. We welcome Aarti. Big hand. Stage is all yours. Thank you very much.
Thank you, Kaushik. Thank you, everyone, for your interest in this very exciting topic, data science and analytics and machine learning as emerging technologies to power business growth. Am I audible at the back? Okay. Is this better? Is this better? Okay. Kaushik has given a good detailed introduction of myself. I'll just add a few more points. I have been with Fractal for about 3 years, overall about 10 plus years in the analytics industry, which was never called analytics since a few years ago. And at Fractal, we have been in the business of doing analytics, driving this growth for the last 15 years, and now it's getting recognized by business like a rage, like a wildfire. So today, what we will cover is we will start with an overview of machine learning, data science as emerging technologies. Then we'll talk about how these technologies are influencing us on a daily basis, how these are being brought to businesses, and how businesses are driving competitive advantage by exploiting these technologies. Towards the end, we can go through a case study, time permitting. I would really appreciate if this is an interactive session. All of you have diverse experience, been with the industry, been studying, maybe using machine learning algorithms. So your experience and your ideas will contribute towards making this workshop successful. So how many of you are data scientists here? Okay. So it will be an introductory topic then. Have you been using machine learning in your, okay, one person, okay, thank you. So whatever you want to add towards the discussion, please do so. If you are even thinking about using data science, machine learning in driving your business decisions, it's a great start to start thinking about it right now, because soon it's going to become, it's going to be mainstream. So, reports say that machine learning, data science is going to be a $20 billion industry, in 2020. What is all this, right? We started with machine. Okay, my slides are not getting projected. Thank you. Okay, so I'm saying that machine learning, it's not new. We started teaching machines many decades ago. We started teaching them, as basic as 2 plus 2 is 4. Calculators and computers came into being. Eventually, they became smarter. We got a personalized computer. Everybody had a computer in their homes. Then IBM developed this computer called Deep Blue, who started beating the grandmasters at chess. So computer science started evolving. It is still a young discipline, but it became a field of study and it started evolving. Then came this term called data science, and very soon it became the coolest thing on this earth. What is data science? Right? Data science is basically a multidisciplinary field which brings together the traditional age-old field of statistics and combines it with the recent field of computer science. And why is it called a science? Is because it is more experimental, it is empirical, it is driven by testing out different algorithms on real world problems, business problems. And it starts from getting the data, processing it, making it ready for use, building models on it. And those models have always existed in statistics, but now those models are starting to drive business outcomes. They're starting to drive meaning for businesses to take decisions on. And therefore, this field has started emerging. Now, data science, machine learning, they start solving business problems or problems which we did not even think need to be solved. Let me tell you a story about stories, right? So, do you know that every story has some arcs, like an emotional arc? For example, in a simple story, man falls into a hole and man gets out of a hole. So it's a fall and then it's a rise. And that's like an arc. Another story is a boy meets a girl, boy loses the girl, boy gets the girl. This also follows an arc, that it's a rise and a fall and a rise. Well, I mean, debatable, but it's an arc. As the stories become more complex, they become sagas, they become novels, there are multiple arcs in the stories that are there. And how are these arcs perceived by data science, by understanding how the story is formed, is by evaluating what words are in that story. For example, Alice in Wonderland, when we read that story, we get a very positive vibe from it, because it's a story from rags to riches. It's like a positive, ever-increasing arc. And it's like a happy ending, good story, feel good about it. However, a story like Romeo and Juliet, it'll just go down. You will expect what the arc will be, right? You will expect it to be ever falling down. And how does data science understand this? Is, as I said, right, understanding, building chunks of words or breaking it down into words and seeing how the words are changing, doing sentiment analysis on those words to see how the emotions of people who are reading the story will change and what kind of arc will this story follow. So once we start understanding these arcs, okay, I actually wanted to take you through I mean, it's like the person who's been doing this research, they have formed different arcs of different books, and you could actually see that, one second, I'll take you through that like this is the arc of Romeo and Juliet in actuality. And if you compare the section where there is the happiest moment with the section which is towards the end, you will see that the words change from having, they change towards tears and weep and die and death, and therefore the emotion becomes negative and sad, and therefore it becomes a tragedy. So now that people could study this in detail of how there are emotional arcs in the story, people would also begin to understand that what kind of stories do people like? Which book, if it's like an online Kindle, and if we track how many Romeo Juliets were downloaded versus how many Alice in Wonderlands at any moment, or similar kinds, we would realize that there are certain kinds of arcs which people like. And once we start understanding, or a machine starts understanding, that if a story follows a certain arc, it is liked by people, it could probably start writing stories as well. That there is an emotional arc that I want to write, that I want to create, because that's liked by public. A computer understands that, and possibly the next Bollywood movie that comes out is actually written by a computer. And it becomes the rave, because we understand that people are liking this kind of an arc these days. So that is an example of how machines are getting smarter, and they are starting to influence our daily lives. There are many more examples, right? Why don't some of you share, how did technology or how did machines influence you today? Would anybody want to come up with some examples, some things which you thought? I mean, your phone, of course, is the best example. Sometimes it just makes you think, wow, how did it know that? But would you want to add some experiences just from today, from your daily life, of how you think that machines are becoming smarter. Perfect. Uber app, and it figures out your travel pattern.
Is it audible? Okay, yeah. So one thing I notice is that if I'm talking to a random stranger over a phone and I open my Facebook, I get a notification like add this person as your friend. Okay, so
exactly.
this is something amazing that technology has been doing. We are talking to someone else, the Facebook algorithm is tracking that person and is showing us that, you know, you can add this person as a friend. You know, it's one way that how technology is influencing my daily life.
Yes,
Thank you.
Absolutely. Thank you. Excellent example. Anybody has any other examples too?
Ma'am?
Go ahead.
The biggest example I noticed is like I use an Android phone and I use Google Now. And normally I stay in an apartment near my office, but at every Friday I go to home. So on the Friday morning, every Friday morning, Google automatically knows that I will go to home, and it automatically shows that it will be 2 hours today to my mother's place. So that's how it knows that I already traveled there, and it shows the cards which is relevant to me.
Exactly. Isn't it scary also, right? So much machines know about us. And I mean, I also put down these basic examples from our daily lives that I have to travel to Kolkata today. So my Google now knows it and also tells me that this is the temperature, so I should not have, you know, sweaters on. And it also tells me what is probably the traffic from here to the hotel that I have to go to, because Google now has all my emails read and figured out that this is my plan for the day. Or your WhatsApp, right? It might have started with an English dictionary, but none of us now use English as the only means of conversation. So it is able to figure out, and it logs your commonly used words and also starts recommending that after you write this word, this is the next word that follows. It's become so easy, right? Life is becoming easier. And what is running behind, right? There is technology. There are these huge engines that are churning out this data, storing this data. There are these algorithms which are running on top of it. So you might have heard these algorithms at some point. You know, linear models. You know, if you even think about class 7, when we learnt about a line, and a line is, the equation of the line is y is equal to mx plus c. That's like a linear model. We extend it to add some more parameters. It continues to be a linear model. There are more complicated matrix multiplication, factorization models. Then there are other models like decision trees. And then the newest word that's been doing the rounds is deep learning. These algorithms have been reflecting on our daily lives through some of these examples. We browse through Flipkart, and there are recommendations for a person like me based on my purchase history, based on my current portfolio, what I like, what they have figured out what they like. There are, if we type in Google that I'm looking for a cat, Google just has images of cats, right? But how does it match the word cat to those images? And it's able to figure out from that image or read from that image that it's a cat and would pop that image up in front of me. Or ad clicks or fraud detection. All of these algorithms on the left are contributing to these algorithms or these programs which impact our lives. Do you know what could be solved using linear models? Like, can we do image recognition using linear models? No, we can't do. It's just too simple. We can do something like ad clicks through linear models. Something more complicated like fraud detection or something like recommendations. Fraud detection, you need decision trees. Recommendations? You could use, I don't know, neural networks. I think you can use for everything. But yes, recommendation is a good way of, could we solve? Yeah. So neural networks will probably these days solve a lot of problems. But we could even use simple factorization, matrix multiplication models to solve recommendation problems. But when it comes to something like image recognition, you definitely need deep neural networks. Sound recognition, text recognition. You don't need neural networks, but when it becomes more complicated, when you're analyzing books, you need to understand, probably neural networks becomes a better way of solving for that. So now that data science and machine learning is so mainstream, it needs to be accessible to businesses also, because businesses need to, now businesses, it's become a no-brainer, right? That why will businesses not start using it? For example, Uber. If Uber doesn't recognize its customers, then Uber has no use, right? We will figure out our way. If we have to figure out our way ourselves, then we don't need Uber. But because Uber knows that I have, or maybe if Uber knows that I have a flight to catch at 7 a.m. this morning, Uber, it makes sure that a car arrives for me. Then it becomes all the more reason that I start using that. So businesses are starting to use these technologies extensively, and these technologies are also becoming easily and more accessible to people. For example, what are the, so if you just think about what are the emerging trends, what are the keywords that you keep hearing about, data science, not data science, but even in terms of technology, what do you hear the most these days? For example, big data. It's existed for a long time, but other words that may come to your mind when you think about deep neural networks, as somebody said. What else could be the common things that are business intelligence? It has existed for a while. That's how analytics started. It was the core of analytics. Other keywords which you might. Cognitive, again, it's been around, and it's a key part of analytics, and it's been there. What else? Algorithms, artificial intelligence. Artificial intelligence, again, if you would think of it, when computer science started, was when artificial intelligence started. But now everybody talks about it, because we know that it is affecting us. Exactly. Cloud is another very important one. What else? Predictive modeling. Internet of Things. All of the terms are out there, right? Absolutely. Unstructured versus structured data. Yes. Absolutely. The big data has a more diverse concept. It is about volume, large volumes. It's about variety, different kinds of data, unstructured, structured, and about veracity, how fast it is changing, how do we want to make things real time. So these are the important keywords that we have been hearing, and they are becoming important for us. So what are the emerging trends? Firstly, information is becoming a commodity. People are using it to, people are monetizing data, people are storing data, and it's become like, people say that data is gold. That if you have data about anything, you can actually use it, exploit it, drive a lot of business value, and people will be willing to buy that data as well. For example, credit card companies, if their biggest asset currently is the information they have about their customers, they can use it to find different patterns, their best customers, etc. Then, as you said, Internet of Things, right? Everything is connected. There is machine to machine, or will get connected in the future, in the near future possibly, that Uber is connected to Google, which knows that I have a flight to catch, and it knows that I have to go and attend this workshop, which is a formal, professional one. So I might need to buy new clothes, and that gets known by Amazon, and then Amazon gives me recommendation of clothes which I like, and I end up buying them, and they get delivered to my home. And where there is another, probably an automated system which can collect them, iron them, and put it in my wardrobe. Eventually, a world where everything is connected seems like a reality now. Cloud is a very important player in all of this. Cloud is starting to allow us infinite processing capacity, scale, and it is now being used more and more for the newer technologies. People used to have huge data centers in their companies. Even at Fractal, we have huge servers, and we use that for data processing. But let's say we want to explore the latest, newest technologies. Is it wise to set up an instance or server and just for testing? Why don't we just commission it on the cloud and decommission it when we do not want to use it anymore once our testing is done? So cloud will continue to evolve. Even today, there are many of our clients who say that, cloud, we are not sure, is our data secure there? We don't want to go to the cloud. But soon we will start seeing people open up to that. They will start realizing what is the immense value that cloud computing is bringing. Then, okay, I thought is there a question? Then, the other thing the other thing that is developing now is active intelligence. Or as you said, right, predictive modeling has existed for some time, but now it is becoming 24/7, real time. Everybody says, I want outputs, insights, real time. I want to know about my customers, real time. I want to know about the weather, about the traffic, real time. And that is called active intelligence. Artificial intelligence was there, but active intelligence is important nowadays. People are getting more and more sensitive towards it. Businesses are getting more and more sensitive towards it. The other two important things which are getting into the DNA of businesses now, one is, again, another keyword, data democratization, which means that data is becoming a core thing for businesses to store, analyze, and use it in their business processes. So every decision, every outcome, every business meeting should be driven by data. Business intelligence was the earlier keyword or earlier vision of how this would reflect. We might get data, do some simple analysis, dashboarding on it, and get outputs. But now it should be embedded in every process, be it supply chain, be it marketing, be it our R&D labs. Everything should be driven by data, analyzing the data and outcomes. And then on top of that, how the data science element plays a role is about storytelling and bringing all the stakeholders together. So in addition to what statistical models and computer science have been doing, what data science adds is that whole layer of storytelling. The data needs to tell a story. And that is becoming very important for businesses. So our clients used to, at Fractal, our goal was to make analytics institutionalized within organizations. We started driving that 15 years ago, that every decision, every thought that comes to an organization is driven through data and insights from that data. But now it's becoming a reality in the true sense that businesses are realizing the power of that. Analytics is more immersive, data science is more immersive, and it is helping us drive more insights and business outcomes. All right. So other companies, the big names of the world, are also helping in lowering the bar of, as they call it, data and analytics literacy, which means that they want the masses to have access to their algorithms, like the Microsofts and the Googles and the Amazons of the world. They have open sourced their machine learning algorithms. So the Google prediction API, like TensorFlow, there are various algorithms which Google has built over the last 10 years, and those are available at TensorFlow, which include their image recognition algorithm, their speech recognition algorithm. And you will say, what is the benefit to them? Why would they want to open source their algorithms? And that is because in this rapidly evolving world where there are brains residing in different parts of the world, they want the access to their algorithms to be made available to them, because we don't know what is the next big change that everybody can drive. So it's becoming more of a collective effort of how do we take this to the next level. And it's amazing, right? When we have an image recognition algorithm which Google uses, and we get that, and we start building on it, we have saved 10 years of effort, 10 years of maybe 100 people of effort that we can now use, start with it and then build something of our own. Or we can use it as it is and it, have no idea what's going on in the background, but we could still drive outcomes from it. For example, if there is a company like L'Oreal and they want to test their creams on people's skin, right? So for different complexion, they will want to, so if somebody has a fair skin, they would need a different kind of a cream that the person will have to put on their skin. When they put it on their skin, there might be some reaction with the skin and the skin might become better. But they want to observe that. And how do they do that? They capture images. They photograph that person, whoever are their guinea pigs, so to say, who will test out their creams. They will photograph that person and see how is that positive impact on the skin. And how does that algorithm understand? It's through image recognition. You can actually see different pixels and see on the face, face becomes like a pixel, the different parts of the face, and then you can see, okay, there was this acne there, and then when this cream was applied, that acne went away. And through image recognition, the company can understand that, okay, fine, this cream is working. That's just one example, but there could be so many other applications of these algorithms that are available, and there are, of course, so many people who are building on top of these. At Fractal, we have realized that it's becoming more and more important to scale our data scientists. We have a small group of people who are solid data scientists, but we have 20 clients who have 200 people each who want these problems to be solved, the business problems to be solved. So our data scientists need to be scaled. And what they are doing, their work need not be available or need not be understood by everybody, but it could still be usable by everybody. So scale is becoming another important thing that is driving how the thinking of companies is moving. Like the companies who are analytics players, we are making our structuring and standardizing our algorithms so that they can be scaled for applications into different use cases. For example, as I said about image recognition, that's L'Oreal creams is just one example, but different businesses could be using this for different applications. The algorithm should be ready so that it can be used. Creative minds can think about it of how do we use this algorithm into different business applications. I wanted to take you through or give you a glimpse of how Fractal's centralized analytics environment works, which is the product that I work on, but I do not have access to the internet right now, so maybe we'll catch up later, or I could send this to you if you are interested to learn more about how we are building these standardized scalable algorithms to solve various different business problems, and how those are being very well received by clients because they don't have to go into that gamut of what are machine learning algorithms, what is data science, what is happening to this world when Internet of Things will come in, etc. It becomes invisible to them. They get their business problem solved, there is a story on top of it, their data gives them insights into how they should drive their business, and that's all that they need. All right. Now I would really want to open this floor up to everybody for you to share your thoughts on how these technologies seem to be affecting even businesses. How have you been using some of these technologies in your daily work? How do you think that eventually these modeling algorithms, machine learning, data science could really impact business growth? Please.
Hi, my name is Varun. I run a startup in the logistics sector called Truckall. So, time and again we get this, we sit back and we someone who's well versed in the analytics space, and we come back with an answer that that's just not enough data for us to bring out any analysis or So just want to understand how much data is enough data, or I mean, is there an answer to that question?
It's a difficult question. Anybody has that answer or want to answer that question? Please. No.
No, what I'm trying to say is that time and again we get back this answer from a lot of data analysts that it's not just enough data to bring out something meaningful out of it. So I mean, just the question is how much data is enough data to
I can just answer this. I run a small energy analytics company based out of Calcutta. What we do is that we're not, of course, at the scale as Fractal is, but I am basically a physicist. I'm a physicist as in I only did honors in physics, and beyond that I did nothing. But the answer to that question is I think the way it's being sold, the way analytics is being sold. So you often hear about big data, you don't hear about data. You go to Twitter, you would do hashtag big data, that's more prominent than hashtag data. So the way we go back to our clients and talk to them about data analytics is about what layer that you really want to go into. So we are looking at industries. What is in fashion right now? But before you could understand machines, you will have to understand your process. How does the plant overall really work? And you have enough data to be able to do that. So it's a gradual, you sort of widen the horizon of data both vertically and horizontally as you move along. So I think, and also probably one of the answers is that it's just that we have been making data analytics and big data a bit too glamorous. We could talk about small data, the impact and insights they could drive, and once people start to see the benefits of those insights, I think the widening could happen. So it's just about how you really go to clients and talk to them about, or even internally our organization as well.
Thank you. Varun, I would say that, as I missed your name. Okay, so as Umesh was saying that from the data that you have, there are certain kinds of insights that you can derive. And traditionally, companies have been okay with it. Right? As you say, that I'm not happy with the kind of insights that are coming from this data. And that's why these things like Internet of Things is coming up, that not just one interaction of this client is enough for me to know everything about that person. You need to capture every interaction. You need to capture buying patterns, you need to capture daily activities, you need to capture how I behave, how I act, what I talk, what I eat. And once I'm able to capture all that is when I can build a holistic picture of that person. And so we have, at Fractal, we have this product called Customer Genomics, which aims to actually figure out what this customer is. Likes, dislikes, habits, hobbies, etc. And once we have that information, we develop a customer footprint. And that footprint basically tells, it's like genome. It's like a genome. Exactly that's what genomics is. So for that, we need diverse data from diverse areas. For example, P&G, right? P&G will have information about their customers. They have their own websites. People log in, people purchase on their websites. But that's not enough. They go to Amazon and they say, can you give me reviews of these people for the products that they bought? I want to learn about their customers. And then the P&Gs of the world will come to Fractal and say, okay, now I have these reviews from Amazon. Can you please figure out what these customers are saying and what they like, and how should I send my newsletters to the customers? So it's never enough. Data is never enough. But whatever we have, we can solve some problems from it. Yes, please.
So recently we were building a model for a bank where we need to come up with a loss rate when we are selling the properties, and then again there was very less data. So the bank in that particular market was not willing to foreclose many properties. So we were having a tough time. There's no data how to come up with a loss percentage. So but then the human intelligence came, and then from the foreclosure team, one guy said that actually when you sell this property, the cost is the renovation of that property. So then even if you don't have data, but this is where the human intelligence came, and he came up with a proxy that, okay, usually the 10 or 20% of the property takes to renovation. So that is the loss for the bank. So I think the human intelligence or the expertise in that domain sometimes helps to fill up that data gap.
Perfect. What's your name?
I'm Rajiv.
Thanks, Rajiv.
Hi, myself Partho. let's discuss a business problem. What we do is we sell different materials through our auction system and procurement system. The data we have is in some form it's a structured, some form is unstructured data. So for example, we know the chair is sold, but we don't know, and we have the price range. But the problem is we don't know the chair with a certain specification, what was the price. Because this is in the unstructured form, this is in free text. Now, my question is it possible to use the machine learning to predict the price based on some structured and unstructured information? And in that case, what would be the best models suiting this purpose?
Anybody here who would like to take that question or has worked on such a problem? Okay. So the answer to define the best model is very difficult, at least in my experience. Without doing 20 iterations and trying out different models, I have not been able to come up with an answer. But without looking at the data, again, it becomes difficult. But to answer your question in terms of if it is possible, absolutely. So now, as you know, as Varun was also saying, that we have some structured data and it only solves so many things. But that unstructured part is the real gold these days. Although still, the problem still is that unstructured data is in a very messy state even today. Right? Sometimes you're not able to extract anything out of that data. But it is the beginning. Right? Now, even once you start capturing that unstructured part better, you start capturing, getting reviews, getting feedback, tracking different, the different ways the customer interacts with you, then you will be able to extract a lot of different things. Typically, there are a lot of machine learning algorithms like text mining, like topic modeling, like sentiment analysis, where you are trying to extract some information about through unstructured text. These are the common names that are there. You never know, how your data is structured. Will they be actually useful or not? But these are some algorithms which have worked with some of our clients, especially in the financial domain, insurance domain, where you have your customers' structured data, which are the logs, but also you have different unstructured part to it.
The question is, just a continuation, what is asking structured and unstructured, both part. Now, what is your approach? I mean, you take it as case-to-case basis, or you have a definite model to go ahead,
No, never a definite model. It is definitely case-to-case. About 3 years ago, we would only look at the structured part because it was too difficult to get anything out of the unstructured data. Our financial service clients and our insurance clients, mostly we would solve the problems through structured data. But of course, how do you code every variable? That becomes important. Where again you need science. You need science to figure out should I take this person's interaction as a 1-0, or should I capture different types of interactions that we have done, and that would bring out a different element of how that customer behaves. If I capture the age of that customer, should I capture it in brackets? How do I define those age brackets? Is 50 plus and below 50 enough, or should I do a 10 to 20 and 20 to 30? All of these become very important decisions when we want to figure out how people are and what are the different elements of different customers, or classify different customers. Only now this unstructured element has started, because it is better captured and you can get better insights out of this, is becoming more important. And as you said, right, it can take us 2 months to even figure out what model will give us good results. And it becomes definitely case-to-case basis.
So your steps are not definite.
The thinking at a broader level is defined, that this type of data comes in, this kind of things can happen, these are the logics, these are the hypotheses that we should test. But how many hypotheses?
And probably the expert has a lot to do on that.
Yes, always. Like always, the analysts have to play a large role. So even if as part of CAE, the environment that we are building at Fractal, where we are trying to codify this process as much as possible, right? In the old world, it used to be a completely new problem each time we started out. Now we are saying that, it's been 15 years, we have solved 15,000 problems of this kind. Why don't we, at least put some metrics around it?
Correct.
So when we get to that list of hypotheses, that list becomes 100 hypotheses, 120 hypotheses. You say, how do we bring that down further? Never mind, we still have come to 100 hypotheses, and now we know that, okay, we have to test 100 hypotheses which are defined. I don't have to do research to figure out what are those 100 hypotheses. But again, it's like an art, right? It's not mathematics anymore.
Thanks.
Any other questions, your thoughts?
So I was wondering how feasible it is to utilize online learning instead of offline batch learning, where you don't actually have a model to start with and you have really little data, but then each data point would actually calibrate your model and make it closer to the ideal function family that you're looking for.
Okay, what's your name?
Manvi.
Manvi. Manvi, what do you define as online learning?
So like you use each data point to, you use incoming on-stream data, like you don't use data as a batch and like have a validation set and a testing set, etc. But then you use each data point as it comes, and then you use it to actually calibrate your model. Like there's a new paradigm which, departs from offline learning that way.
So you're saying that in real time you want to understand your customers, or
Yeah,
your model evolves? Yes, that's exactly what machine learning is, right? That you don't have to stick to a model or define a model now and then stick to it for the next 2 months. Your model can evolve and should evolve based on what you're getting in real time. And that's picking up. Of course, managing that data in real time, there are those streaming engines that need to be put in place. There is a lot of technology that has to support it. And then we should be able to build those models in real time also, so that they are applicable. That is developing, that's becoming more relevant now. But traditionally we used to have only batch, right? Historical data, build a model, get the outputs, and that model sticks on.
Okay, just one other thing. I mean, big data is becoming like a huge thing these days, right? I mean, do you see any limitations actually to the use of big data? We know the usefulness. Are there any limitations?
Anybody has answers? What are the limitations of big data?
Which data to capture. For example, I'm building a new app or a new product, then how do I understand that these are the areas where I need to capture the customer data? Otherwise, let's say I have an existing business, I have a bank and I run a bank, and I have some customer data already. In that case, it's okay, and I use that data to identify something and solve some problems, and then I evolve from there. I start to capture some more data and more data. Now I'm starting something new. I know my product. I know that who my target audience is, but how do I know which data to capture? Because I can't go on and capture 100 things. I need to be able to capture 10, which I will actually use, and not create an app that will not be used in the future.
Yeah, it is. I mean, usually we also start with a business problem, and then when we start breaking down that business problem, we start understanding that we might need this kind of data to support that analysis. So what is it that you have to solve should be the driving factor of what you should capture. Our clients do not know what they should capture, right? They have not been doing analytics. But when they come to us with a business problem, we ask them for certain kinds of data. And then sometimes they have it, sometimes they do not have it. So their answer to that problem becomes subsetted. based on what is available. So if you have a clear, and if you are building your own product, I would suggest that you should start thinking about what is it that you want to get out of it, right? What is it that you want to solve? Do you want to know about my interaction? You want to know about my likes? What do you want to solve for? And once you have that understanding, you could start small. Start thinking about the first few parameters, use that to solve your problem, and then you know, okay, I am missing some other parameters. And that's when that thinking will evolve.
Is there an example in your life that you've faced?
Like what could... yeah, sure. I wanted to cover that as a case study, but we have only 10 more minutes. But for example, like every company, they end up forecasting their demand for the future, right? Whoever is building manufacturing companies, they're building products for consumers, CPG companies who are building consumer goods. They want to forecast what is the demand of my product, and they want to know how should I plan my manufacturing process for the next 1 year, 2 years. Every company has to do that. When the company becomes like a Unilever or a Colgate, they might have to do it more so because they have these manufacturing plants scattered all over who need to define their targets. So in the boardroom, when they have to forecast that demand, how will they do that? What they start off with is, okay, tell me what is the historical trend, tell me how much was sold last month and 2 months back and over the last 3 years, and I will just project it. I will just do a moving average or use a time series approach, and I will get the forecast for the next 2 years. Okay, that is fine, right? We've been doing back of the envelope calculations. We've always done this. We will say, okay, last month I sold 100 toothpaste. This month I will sell 102. Maybe how much more can it go up? But now you can start thinking that how did I come up with 102? I know that my population is growing at a rate of 10%. I know that I'm going to start my operations in Singapore. I was only in India earlier. This has to be captured somewhere. Now, if my operations are in Singapore as well as Japan as well as Australia, I need to cater to that demand also. Now, in Singapore, there is a major a competitor for selling toothpaste. How will I have a market there? Now I have to capture competition. There is no, there is no scope that I can sell toothpaste there. So now competition is there. Now you've captured the competition data. Then you realize that in Australia, they only drive promotions. Your competition is driving promotions. We are not doing any promotions. So because of no promotions, there is no toothpaste selling. Then you capture promotions data. And like that, you start adding and adding and adding to what all you can do to calculate how much toothpaste will I sell next month. It's a simple problem. You're not even talking about knowing any customers or knowing about my habits or anything. You have to just sell toothpaste. But these are the problems which our clients are facing. And when they come to us and say, okay, you tell me exactly to the last unit of how much should I manufacture. How can we tell? We are not gods. That data has to be captured. We have to know how the market is performing. We have to probably know what Apple is doing in that country to figure out what is the toothpaste sale. You never know. There could be so many interactions, so many different things, different levers which could interact. It's a complex problem. We come up with some answer which is sort of satisfactory, but then we explore for more. Okay. Yes, I thought you'll answer some questions.
We mostly talk about, having more customers, increasing, but, holding on to existing customer is also an issue. We do upsell, we do cross sales. We also do a lot of churn analysis, who is actually going out of our hand. So, can you put some light on churn analysis, how actually analytics can help doing the churn analysis and run a campaign to hold on to our existing customer base, or even to upgrade as their existing spend, and upgrade them from existing spend to higher spend. How do we actually, what is the basis? How do we actually blend statistics with analytics and do it actually on real life?
Got it. Anybody wants to? Sure, Varun. I will add to that.
Hello. Yeah. So it's a lot to do with probably taking a footprint of what the customer is doing. So for instance, I was working, this is back in my college days, we were working on a project where we got this huge dump of file from AT&T, just flat files, and you were understanding the calling behavior, the calling patterns, their billings, and how much calls were they making within their circle versus how many calls they were making outside the circle. So if a user is making a lot of non-AT&T calls, so that means all his friends have shifted to outside AT&T, and he would want to soon migrate. So that's the user you try to basically target. So it is again specific case by case, wherein I remember working with Sears for some time, wherein they would just shoot out a discount coupon the moment they know that the person is going to log out. So it was a lot to do with capturing the footprint of the customer while he's on your platform.
Great.
I don't know if I answered
Yeah, that's a good answer. I would add another example that churn is, as you said, right? That's like the biggest fear of every company, because acquiring new customers is one thing, but if you're letting your existing ones go, it's a big problem. So recently we solved a problem for a bank where we could figure out a sequence of events which led to attrition. So, what would I do? How will my behavior change if I am about to attrite? And so a sequence of events could be that of course, transactions have gone down. I'm not taking my calls. I do not act. I have not maybe paid my bill or want to, not pay my bill. There is some trend, erratic behavior from me. There could be some sequence of events which will eventually lead to my not being engaged with that bank anymore. And when we solved for that sequence, looked for the sequence of what could lead to it, we were able to figure out a pattern that what set of activities end up making a customer attrite. Once we can figure that out, those steps, initially we might be able to capture at maybe the final step that, okay, this person is about to attrite. If we are able to capture the 5th before final step or the 10th before final step, then we can either send coupons, we can reach out to the customer, figure out how that customer can be made happier, stuff like that. So sequencing is one example or one way of how we can track if that customer is a potential risk.
Yes, I think we can take a couple of more questions.
My question will be on the other side of this business. We talked about the problems of business, how to solve. About the supply. My question is, what kind of skills, educational qualification and attributes make for a good data scientist? So over your experience, what kind of people do you hire? Do you hire freshers or experienced people? What qualifications and attributes do you look for in a potentially good data scientist?
I'm sure Varun, Rajiv.
Yeah, I'm Kaushik from IBM. So I don't work in the analytics part of IBM, but I just wanted your view about what kind of people you hire in this business.
Sure. So I'm an engineer, and then I did an MBA, and I've been solving some data science problems. I don't know, data science is a very loosely defined term, right? But it's a mix of many things. You need to know technology, you need to know statistics, you need to know storytelling, as I said, right? You need to know business, right? So at Fractal, we have four different streams: big data engineering, data science, analytics consulting, and business intelligence. And all of these actually combine together to probably make a good data scientist as well. That you need to know what is the business problem, you need to know what model would solve it, you need to know how technology will support that model, how will you get the data, clean it, and you need to know how to present it, how to tell the correct story about the data to the business. So it was very difficult, as in there is no defined skill set now that it's become so ambiguous. So over the last 10 years, we've been hiring engineers, we've been hiring economists, we've been hiring statisticians, to, so that there is a good enough mix in the whole group who can probably break this down. Now there are streams which are emerging as data science. There are courses which are again a mix of all of these things. So it's been a difficult journey. I'm sure now it is evolving as a field in itself where there could be more, specialized people in that area.
Right. Because the reason is, I think the approach you mentioned is the sensible one. You get people with the analytical and mathematical skills, and then you teach them how to think of data. Yeah. These days, a different trend is happening. In IBM, we are hiring designers, people who are from art schools. So we are first getting the thinking part and then teaching them the analytical part or supplementing. So it's look the other way. Instead of taking a mathematician and teaching them how to think, take a thinker and support them with mathematics. I'm wondering whether you people are looking at that approach as well.
No, I mean, not today at Fractal, but whatever articles I read about or know about visionaries, they say that whatever machines can do now, that will become redundant, right? The artists, thinkers, the art school graduates, they might have a role to play, but what engineers can do or machines can do now.
Good, thank you.
Aarti, again, I'm Rajiv. I have a question. Okay.
Rajiv and then yours.
Okay. So I have a question continuation with him. So as the data science, like it's going increase and like with the advancement of artificial intelligence and all. So do you think it's might kill the other mainstream traditional qualifications? Say with the granularities of data, accounting data is available. So do we really need chartered accountant in future? Because I have the data, the machine knows ultimately it's if-else conditions, you do need to this. So do you think in future, like data science will take over from the mainstream professionals?
I don't know. Kaushik, would you want to answer that question?
He was there in Future First. He told me a story way back in 2008, the great fall of US market. There was a guy in USA, he developed a model and he used to tell his clients that this share is going to fall, this share is going to rise, and ultimately that person was jailed by US government, that he must be doing something. But there was some Princeton model, something like that I read some 10 years back. Now that person said that he has analyzed a data of around 200 years and there were so many thousands of permutations and combinations he used. So again, the things you are doing in your company right now is the future, and definitely that is the destructive thing people are saying about. Yes.
Thank you.
Yeah. I am Anirban Guha from Jadavpur University, Center of Excellence, School of Mobile Computing. One point was being discussed, the batch of analytics and all. So I think people know about it. It came out in the paper as well, that ISI, IIM, Kolkata, ISI Kolkata, and IIT Kharagpur, all of them collaborated in a very particular fashion to make it a 4-semester, 2-year course, 6 months in at IIM or ISI and then to IIT, and last 6 months, the 4th semester would be at a particular corporate for the applications. So as it always happens, they have started off. Maybe it is already 6 months old, but gradually, as a gentleman from here was talking about IBM, that gradually other people can also join, and there may be requirement of other people from other disciplines as well.
Excellent point. One of my team members went to join that course, so I'll ask her what her experience is. I think
I think this is a very, very huge topic. The data security itself can be a 2-day workshop. So, madam, I think we have to break out for lunch. And thanks everybody. Sincere thanks to Aarti for such a wonderful session. And we all should give her a big round of applause. And hope Aarti must have liked the Kolkata audience. And we are very, very privileged to have
very, very senior professional with us, Mr. Viresh Oberoi, CEO M Junction. Sir, may I request you to give a memento to Aarti? So, okay. Thank you, Mr. Viresh Oberoi. A big round of applause for Mr. Oberoi also.